Hello students, so let's try to solve one very nice problem from IE Irodov. And this problem is from special theory of relativity. Mainly this is the kinematics problem. So this is a wonderful problem. So पहले मैं इस problem को आपको बताता हूँ क्या है ये, और then we will try to solve it completely. And साथ साथ हम इसके basic theory को भी discuss करते रहेंगे. So let's try to see it. What is given? The two particles moving in laboratory frame of reference along the same straight line with same velocity, and that value is 3 by 4 c. So v is given, and that v is basically given as, so this v is given as 3 by 4 c. Both particles have same speed and strike against the stationary target. So both particle will strike against the stationary target with the time interval delta t is equal to 50 nanosecond. So the proper distance between the particle prior to hitting the target. So हमें इसमें निकालना है कि proper distance क्या होगा particle का before hitting the target. उन दोनों के बीच की proper distance क्या? So we have to just try to calculate this one. So this is a very interesting problem. So here you can see that both particle is going to strike with some time interval, and hence the both particle have same speed and same direction. That means दोनों के बीच की डिस्टेंस डिफरेंट, तो ही ऐसा हो पा रहा है. व्हाट इज मीनिंग ऑफ दैट? सपोज देयर इज अ टारगेट, दिस इज योर टारगेट एंड दिस इज योर पार्टिकल 1. So let's say this is your particle 1, and let's say this distance is L with respect to some lab. So I can assume this is my some lab. Obviously दूसरी पार्टिकल भी यहाँ से नहीं आएगी because दोनों की स्पीड सेम है. So I can assume the second particle is have this much of distance. So this will be the distance for the second particle, and this is moving with velocity v. This is also moving with velocity v. So suppose this one is L1, this one is L2. So अगर मैं इसे गैलीलियन के थ्रू सॉल्व करता, then what will be the difference between these two things? Is nothing but L2 minus L1 is equal to V into delta t. So ये आपका आंसर होता है. But here you can see the speed of both particle is actually relativistic in range, and that value is basically 3 upon 4c, and that value is also 3 upon 4c. So obviously here you will see that length contraction is there, और इस लेंथ कॉन्ट्रैक्शन का कैसे हम यूज करेंगे वो हम समझने की कोशिश कर सकते हैं. सो ऑब्वियसली वी शुड नॉट यूज द गैलीलियन फॉर्म और न्यूटोनियन की जो बेसिक चीज होती है वो नहीं होगी, बिकॉज इफ योर पार्टिकल इज मूविंग विथ सम स्पीड विच इज अप्रोचेबल टू स्पीड ऑफ लाइट, there is length contraction. What is meaning of that? Meaning of that, if you will see with respect to this particular sigma, then this length is L1. But if you will see this length with respect to this particular particle which is moving, then this length is going to contract. And that is basically known as length contraction. So, and what is the proper length? The proper length is the length measured by the observer which is rest with respect to that particular length. That means if we will attach to sigma, then we will see that proper length of this one is L1 and proper length of this one is L2. But if we will see this thing with respect to these two particles, then this length will be also contracted and this length will be also contracted. So let us try to solve this problem. So what I can assume this length is something, this L1 is something capital L0. So I can mark this point, and this point is also nothing but capital L0, and this length is small L0. And what we have to do, we have to calculate what will be the proper length before hitting the target. Proper length. That means if we are seeing with respect to sigma, this length will be always remain proper length before hitting the target, because at the same time this particle will also move this length, this particle will also move this length. So remaining length is this one. So we have to calculate what is value of L naught. And this will be always there. So now how we will write all this story? So we will write the basically kinematic equation. So what is that particular kinematic equation? For this particular particle, let's say for particle 2, the complete proper length is equal to L naught plus small l naught. So this will be L naught plus small l naught. And this particle is moving with respect to this sigma is 3 by 4c or some velocity v. We can also assume that with respect to this particular particle, this length is moving, so it will not remain proper. It will basically contracted, and that value is 1 minus v square upon c square. This is for the second particle. And what about for the first particle? The first particle is also moving with the speed v. That means with respect to this observer, this length is going to move with the speed v, and so why this length is also contracted, and this value is equal to 1 minus v square upon c square, and that value is nothing but v into delta t. So this is your length or kinematics equation, and when we are going to solve this thing, this value is equal to L naught 1 minus v square c square is equal to v into delta t, and we can get this L naught. That will be the proper length, before hitting the target. So that's L naught is equal to, we have v delta t upon root under 1 minus v square c square. So now we can put all this value. So आप पूरी value put करोगे, and this value is equal to 3 by 4 into c. So c is 3 into 10 to the power 8. Delta t is given 50 nanosecond. So that value is 50 into 10 to the power minus 9. And obviously this value is 1 minus v square c square. And when we will put this value, that is 9 upon 16, that means you have this value is 4 upon root 7. So if we are going to calculate all these things, then this value is exactly 17 meter. So it's a wonderful question to understand the kinematics in a relativistic form. So here we have used the length contraction, and we have used all these kinematics equation, and then we can get this thing. So this is a wonderful problem of Irodov, and any aspirants of IIT JAM, NET, or any physics examination should solve this type of question. Thank you, students.